from the analysis and results from the two-period model. And after that, I'm going to talk about, the models of 3 periods or more, and then some other extensions to the model. And then finally, we will have conclusion and the future research. All right. So I'm not very sure how many of you guys are doing supply chain management research, right? But in supply chain management, we often talk about complete decentralization, okay? CD for short. What is complete decentralization? It means the firms in the supply chain are independent, and each firm maximizes its own performance. So in this very simple supply chain, a supplier sells to a retailer, and the retailer sells to customers, right? So if this supply chain is in complete decentralization, it means the supplier wants to maximize its profit, the retailer wants to maximize its profit. Okay, so they make independent decisions. The other extreme would be complete centralization, CC for short, in short. So what is complete centralization, CC? It means firms in a supply chain belong to the same parent firm. So maybe there's a multinational firm or multi-division firm, right? So in this supply chain, all the firms belong to the same parent firm, or they may not belong to the same firm, but they behave like it. Okay, so they behave like a centralized single firm. So in a supply chain which is in complete centralization, the common goal of all the firms is to maximize the supply chain profit, right? So intuitively, complete centralization is better because the basic principle is you can make the pie as big as possible, then you can share the pie, right? But there's another possibility called partial centralization, PC here. So what is partial centralization? It means at least one firm owns a part of another firm in the supply chain. So actually, we call this partial centralization. You can also call it partial decentralization, okay? Or you can call it some other names like a partial ownership, right? So in this simple supply chain, there are actually more than 2 possibilities, right? One is called forward partial centralization, okay? So if we have a supplier owns, say, 10% of the retailer, that would be a forward partial centralization, right? But there's another possibility, which is backward partial centralization. So if the retailer, say, owns 15% of the supplier, then we can call this backward partial centralization, okay? So when we have backward partial centralization, it means that a firm partially owns its upstream firm, right? You can also imagine some other possibility, right? For example, maybe we have cross ownership, okay? Maybe supplier owns 10% of the retailer, but at the same time, the retailer owns, say, 15% of the supplier, right? So for the partial centralization or the partial ownership, there are also 2 possibilities in terms of how people make decisions, okay? One is called the passive partial ownership, okay? So if firm A partially owns firm B, but firm A has no direct control over firm B's decision making, okay? So this partial ownership may be 10%. In that case, it makes sense that firm A has no direct control over B's decision making, right? But sometimes, even A owns, say, 60% of B, but still firm A will not have direct control over B's decision making. So in reality, there are all kinds of possibilities, right? On the other hand, we may have active partial ownership. Okay, so from A owns, say, 20% of B, right, or even 50% of B, but A do have direct control of B's decision making. As I mentioned, right, both are possible, right? And as you can imagine, it kind of relates to economics, right? In economics, people worry about monopoly, right? So, I mean, there are lots of like laws and regulations which prevent like two firms to collude, right? To collude. So basically, even if you have ownership, it doesn't mean you can affect the other firms' decision making, right? So if you have any questions, in my presentation, feel free to ask. Okay. Any questions so far? So let me give you some examples about forward partial centralization. Okay. In 2012, Toyota acquires about 30% of stake in a company called CFAO. So this is a multinational company engaged in the sale of manufactured goods, especially automobiles and pharmaceuticals in Africa. Okay, so this company is basically a distributor, right? So Toyota is the manufacturer, the supplier. So supplier acquires about 30% of downstream firm. That's forward, partial centralization, right? In 2021, Toyota invested in its distributor in Costa Rica, Purdy Motor, and Toyota acquired 10% of the company's shares. Okay, again, this Purdy is a distributor. So basically, Toyota is doing forward PC, partial centralization, right? Another example, in 2015, Michelin took a 40% of stake in this company. And this is a company, the leading French internet tire retailer. Okay, so again, this is a forward PC, right? Here's an example of backward PC, partial centralization. Okay, in 2021, US automobile distributor HAAH, this company plans to acquire a 51% of stake in a manufacturer automaker for Sangyong Motor in South Korea. Okay, so it's like a distributor owns 51% of its supplier. So that's a backward partial centralization. So we also provide examples here to to kind of emphasize that this kind of PC, partial centralization, is common in this kind of automobiles, right? Automobiles, tires, and those products are durable goods. Okay, so that's why we want to kind of do what we are doing, because partial centralization, PC, is a common supply chain structure in the durable good industry. Okay, number one. But so far, there has been rather limited research on partial centralization in supply chain management. Okay, so the focus of our research is this: we want to focus on partial centralization in a durable good supply chain, and our main research questions are: can PC partial centralization outperforms complete centralization and complete decentralization for durable goods supply chain? And if PC can outperform CC, for example, that would be interesting, because complete centralization means I need to buy 100% of the other firm, right? PC means I only buy, say, 30% of the other firm, right? If I buy 30% of the firm, is better than I buy 100% of the other firm. Of course, I will not go I will not go out and buy buy the 100% of the firm, which is much more expensive, right? So
Victor, may I interrupt and ask you a question just to be sure that we will follow later on what's happening? What makes in this framework specific to durable goods? I mean, what would prevent you from applying what you are considering in terms of partial centralization to any type of good? Is it because you see a lot of companies, for instance, buying upward some providers of raw materials or downward part in their retailers. So just to be sure that I will be able to follow in terms of modeling what is specific to durables. Thank you.
That's a very good question, George. Yeah, so the truth is the research on partial ownership, partial centralization in supply chain, there has been a little bit of research done already, right? And so one of the goals of us is really try to make our, research new and unique. And so our research, considers durable good. We're going to see a parameter called durability of a product.
Okay.
And then durability can be 0. That means any product. Yeah.
Okay. Thank you.
Very good question. So it's more for so kind of try to make the research idea, newer, new enough. So we want to see can PC outperform CC and CD, right, and Y. So let's do a little bit literature review. First of all, there are lots of research on decentralized supply chain. Okay, and then there's corresponding problem called the double marginalization problem. So that's a mouthful, but this is a very classic problem in supply chain management. So because this is very important, so I just want to make sure everybody kind of understand this term, double marginalization. Okay, so let's use this supply chain as an example. Okay, very simple supply chain, probably the simplest supply chain you can ever have. Okay, a supplier sells to a retailer, right, and retailer sells to customers. So if this supply chain is complete decentralized, right, the two firms will be independent. So each firm is going to price at the markup over its marginal cost. Okay, meaning that if the supplier, say, produces this product at $10 per unit, then the supplier is going to charge a wholesale margin to the retailer. So if I produce this one at $10 per unit, I will sell to the retailer at, say, $15 per unit, right? So the supplier is going to charge a wholesale margin of $5 per unit, right? Now the retailer will sell to the customers, right? And the retailer is also going to charge a retailer margin. So the retailer may sell to the customers, say, at $18 per unit. Okay, so the retailer will buy from the supplier at 15 per unit and sell to the customers at $18 per unit. So the retailer margin will be $3 per unit, right? So in this simple two-stage or two-echelon supply chain, every firm is going to have a margin. So that's why then you have double margins, basically, right? But as a result, the retail price to be paid by the customers is too high, and the quantity sold to customers is too low. Okay, because the price is too high, then customers will not buy a lot, right? So people have shown this to be true, that compared with a centralized system or the global optimal system, right? This complete decentralized system is going to have this double marginalization problem, meaning that there are two margins, and then the final price paid by the customers will be too high, and the quantity bought by the customers will be too low. So there are also lots of research on the choice between complete centralization and complete decentralization. Okay, so there are many potential reasons in favor of complete centralization. First, it's going to eliminate double marginalization, as we just mentioned, and sometimes if the supplier and the retailer have different information about, say, the demand, and that might cause information asymmetry problem. But if the supply chain is centralized, then you are going to eliminate this information asymmetry problem if you use complete centralization, right? So basically, most people will say that complete centralization is better, right? And because our research focuses on durable goods, so we also want to mention or basically introduce the research, like the classical research on durable goods. So durable goods have an inherent problem, which is called time inconsistency problem in the literature. Okay, so let's explain a little bit more. So suppose there's a monopolistic manufacturer or retailer. Okay, so the manufacturer produces a durable good. So durable good means it can last multiple periods. Suppose the product can last 10 years. Okay, let's say a model of car can last 10 years, right? Then in every period, the manufacturer is going to produce and sell some new products to consumers, right? So suppose this year I produce, say, 1,000 units. Next year, I will also produce 1,000 units, right? And the third year, I also produce, say, 1,000 units or maybe 800 units, right? So over time, the units of the products in the market will be too many, and its selling price will be too low. Okay, so for example, right, if you produce 1,000 units every year, then in the third year, you're going to have 1,000 totally new products, which is produced in year 3, but you also have 1,000 units of old used products from the second year, right? Because once the product is produced, it's going to last for multiple periods, right? So in the third year, actually, there will be 3,000 units of these products. Some that are new, some that are old, but they are all there, right? So basically, in the market, the units of products will be like higher and higher, will be too many over time. And if you have too many units in the market, the selling price is going to be too low, right? And if consumers are strategic, okay, they anticipate the price decline over time, then the customers will avoid purchases in earlier periods, okay, because they know the price is going down, so they will try their best not to buy in the first year, not in the second year, and so on. So, and then the manufacturer knows about that, okay? So the manufacturer must price low from the early periods, losing its monopoly position. So the manufacturer, although it's a monopoly, but because of the competition between new products and the old products in the market over time, the manufacturer, actually cannot price the product too high, okay? And this is a classic problem called the time inconsistent problem. And there has been lots of research done to address this problem. And one of the obviously very good solution, both in theory and also in practice, is for the firm to adopt a leasing strategy. So if a firm only do the leasing, that means maybe the leasing term is 2 years. After 2 years, all those products will go back to the firm, right? Then the firm is going to decide how many units will be in the market. So this is a classic approach. There are also some other research, talking about other solutions to this time inconsistency problem. But something very interesting is that the time inconsistent problem is too many products in the market and the price is too low, right? If you think about the double marginalization problem, it's basically, the price is too high and the number of products is too low in the market. So as you can imagine, these two problems, they are like the opposite, right? They are the opposite sides of the same supply chain. So individually, those are problems, but maybe they can be combined, be solutions to each other. So that is one of the basic like idea of this research. So now let's talk about the basic model. So I'm not going to go through the technical details. I mean, the technical details is actually not that complicated. You just have to do a lot of analytical derivation and so on, right? But so I'm going to focus on the results. Hopefully, we can understand the results and have some discussion. So a manufacturer produces a durable good and sells to consumers through a retailer. So there's a very simple supply chain, right? The manufacturer sells to a retailer, and the retailer sells to consumers. So here we assume forward PC. So the manufacturer owns theta of the retailer. Okay, so the theta can be anywhere between 0 and 1. If theta is 0, that means the manufacturer owns 0% of the retailer. That means the two firms are independent, right? Then the supply chain is complete, decentralized. If theta is 1, that means the manufacturer owns 100% of the retailer. Then the supply chain is CC, complete, centralized. If theta is between 0 and 1, okay, strictly between 0 and 1, then is the partial centralization, right? So the durability of the product is denoted as delta. Okay, so delta is 0 and 1. So if delta is 0, that means the product is not durable. So the product can only last one period. But if delta is 1, that means the product will be perfectly durable. That means the product will be new this year. Next year is still new. On year number 3 is still new. Okay, so you can imagine something like a diamond, right? So diamond rings, this year, next year, they are the same thing, right? So the degree of competition between new and used products depends on the product durability of delta. So as you can imagine, if delta is 0, very close to 0, then there's not much competition between new and the used products, right? If delta is 1, that means all the products produced last year will be in direct competition with the new products produced this year. So delta is basically the degree of competition between new and used products. So in each period, the manufacturer determines the wholesale price, okay, WT, okay, T means the period, and the retailer is going to decide the procurement quantity from the manufacturer and the sales to consumers. So in this model, we don't have uncertainty, okay? Okay, so if the retailer buys 100 from the manufacturer, then the 100 units will be sold to the consumers, right? By pricing your products, appropriately. So we do have to make quite a few assumptions. Some of them are listed here. One is a classic assumption used in durable goods research. So the secondary market for durable goods is perfectly competitive, and neither the manufacturer nor the retailer has direct control over the market. So basically, it's like there's no leasing. Okay, so it's not like you sell, then you can get them back as you wish. Not as you wish, but you have a leasing kind of contract in place, so you can take back your products. So we assume it's not there. We assume the manufacturer's ownership in the retailer is passive. So the ownership may be 10%, maybe 80%, but the ownership is always passive. And then we also assume the consumers and the firms' discount rates, the manufacturer's unit production cost, and the retailer's unit selling costs are all 0. Okay, so those are for simplification. And because we are talking about durable goods, so we need to have a suitable demand function. Okay, For durable goods, people usually use the inverse demand function. Okay, suppose we limit ourselves to 2-period setting, meaning that we only worry about 2 periods. Okay, so 2 periods on the one hand, that's the minimal number of periods you have to consider, right? Because it's a durable good, so you have to consider the time dynamics, right? So 2 is the minimal. Obviously, a durable good can last 3 periods, 4 periods, right? And then you have to, if you want to do a global optimization, you have to consider like a 3-period setting and so on. But we're going to, talk about 2-period only in the basic model, okay? And here's the demand function. So I wrote the demand function here, it's basically to kind of to remind ourselves that, in operations management, as far as I know, people like to write down demand functions without thinking too much. You can always say that, demand, suppose is a linear function of the price, right? And that will be, so the demand is A minus B times P, the price. And then, the parameter B will be the price elasticity and so on, right? But I think there's one pretty classic paper in Palm, production operations management, which kind of say that all the demand functions have to be derived rigorously, not just by intuition. Intuition often is wrong. So this is the case for durable goods, okay? So the inverse demand function for durable goods is actually a little bit more complicated, okay? For 2 periods, it's not too bad, but if you talk about demand functions for durable goods of 3 periods, 4 periods, the demand function actually can be complicated. So this is the demand function for 2 periods, okay? So I'm not going to go into the details, but if you are interested, you can check it out and we can discuss. So let's talk about game sequence, okay? So we assume there's a dynamic stackable game between a manufacturer.
In fact, Victor, I would like you to comment a little bit on the demand functions, especially the inverse demand P2. If you can say a few words on why is this specification of P2 equal A minus delta Q1 minus Q2?
That's another good question. There's a derivation process, but one thing to understand this is this, okay? So P2 is the price of the new products in period 2. So the product produced in period 2, that's the price you're going to charge the customers, right? Mm-hmm. Now, in the second period, you have Q2 new products, right? Because Q2 is the new products produced in period 2. Now, in period 2, you also have products carried over from period 1, okay? So Q1 is the number of new products from the first period, but because they are used, okay? So delta is also like the remaining value of this product. So Q1 is the number of new products in period 1, but in period 2, that's like the equivalent number of new products, okay? So basically, price equals A minus the quantity in the market. Yeah.
So when you derive this inverse demand functions from consumer maximization of a utility function, so what is the fundamental assumption? That is the market fixed over 2 periods, and the consumer has the choice between buying the first period or second period, depending on the anticipation that this consumer is making on prices? I'm trying to, I see the explanation here you are giving, but trying to figure out the whole demand system.
Yeah, that's another good question. And so I will just try to explain as best I can remember. So basically, every period, the customer demand is the same. okay? Because we are assuming that the secondary market is perfectly competitive, okay? So it's like the first period, all the customers in the market, they may buy, they may not buy. The second period, all the same customers, they still decide whether to exchange or not, whether to buy or not. Yeah.
Okay.
So so there are some classic assumptions, assuming that the customer the customer valuation of the product is uniformly distributed between 0 and A, which is the potential market size. And then from there, you will you will derive, when the customer will buy this product, and by comparing the different variations from different options. Yeah.
Yeah, thank you.
Very good point. Yeah. So if you anybody interested, I can share the details. But right now, let's if you don't mind, let's just continue. So a simple supply chain and a simple dynamic stackable game. Let's assume the manufacturer is the leader and the retailer is the follower. Okay. And each period, each firm makes decentralized decisions. Okay. So in the first period, right, the manufacturer will decide the W1, the wholesale price, and the retailer is going to decide the Q1, which is the quantity to buy from the manufacturer. Also is the quantity to sell to customers. In the second period, T equals 2, the same thing. The manufacturer is going to decide on W2, the wholesale price, and the retailer is going to decide on the quantity Q2. So period 1, period 2, they are kind of the same, but the difference is that in period 2, right, Q1 will be in period 2 as well, because the product are durable, right? So in period 2, you will have Q2 number of new products, but Q1 number of old products, right? So this is the game sequence. And now let's talk about some of the results. The first result is equilibrium outcomes on the CC and the CD in the 2-period basic model. So this result only compares the complete centralization and complete decentralization, okay? So for CC and for CD, right, we list what is W1, what is W2, what is Q1, what is Q2, and what is the supply chain profit, okay? So W1, again, is the wholesale price charged to the retailer in period 1. W2 is for the period 2, right? For the complete centralization, is 0 because there's no wholesale price going on, right? And remember, we also assume the production cost of the product is 0, right? Just for simplicity. And let's focus on the supply chain profit, okay? So if it's complete centralization, that is the supply chain profit. If it's complete decentralization, that is the profit. So the profits are functions of A and delta. So delta is the durable good, right? Sorry, it's the durability, right? So we can verify that under this 2-period model, complete centralization outperforms complete decentralization for any delta. Okay, so it doesn't matter the durability of the product. Centralization is better than decentralization. Okay, now that means for the 2-period decision horizon, okay, the time inconsistency problem is not as severe as the double marginalization problem, because CC will solve the double marginalization problem, right? And here says CC is better. That means probably solving this double marginalization problem is more important in a 2-period model, right? So so that's the first result. The second result is about a PC now. Okay, so now we put the partial centralization into the picture, right? So on the PC, as the ownership share theta increases, okay, so ownership is the ownership of is about how much ownership in the retailer by the manufacturer. Okay, so ownership manufacturer is going to own the retailer, right? So if theta is 10%, 20%, 3%, that means that the ownership is going to increase. As the ownership share increases, the equilibrium sales quantity in each period is going to increase. So again, the symbol here is a little bit complicated, but T means the period, P means partial centralization. Okay, as we saw from here. So we use C to mean complete centralization, D to mean complete decentralization, P to mean partial centralization. Okay, and second thing says the equilibrium wholesale price will also decrease, and also, you know, if you look at the details here, so basically on the partial centralization, right, the wholesale price is between the two extremes. One is the complete centralization and complete decentralization. So this result is actually not that interesting and it's not that important. So I don't want you to feel a little bit confused. But basically, it's like, you know, as we said, as ownership share increases, right, then the supply chain is more and more like complete centralization, right? So as we said, if the supply chain is more and more complete centralized, then the, you know, sales quantity is going to be higher and higher, right? Because you don't have the double marginalization problem, and also the wholesale price is going to be lower and lower, because without double marginalization, the wholesale price should be lower and lower, right? So, but on the partial centralization is in the middle, so which makes sense because PC is basically the middle of complete centralization and complete decentralization. The second result is a bit more important, more interesting. On the PC, okay, the supply chain profit first increases and then decreases with ownership share. Okay, so that means there's a threshold. Okay, so there exists an ownership level threshold, theta tilde. Okay, whatever you want to call it. So this is the threshold. If this ownership share is less than this threshold, then complete centralization is better than partial centralization. Okay. If the ownership share is more than this threshold, then partial centralization is better than complete centralization. Okay. So that means as long as the ownership share is large enough, PC, partial ownership is going to be better than complete centralization. Okay. So this is interesting, which says that PC can be better than CC, right? So here we forgot about the D, because as we said, the complete centralization is always better than complete decentralization. Yes, George?
But how it could be that complete centralization is beaten by any other scenario? Because in the centralized case, you are dealing with an optimization problem and not with an equilibrium problem. So I'm missing something here, if you can explain it a little bit. Because under centralization, it's an optimization problem. The other one is an equilibrium. And the best case scenario, an equilibrium can mimic the result of an optimization problem. So I'm missing something here. Maybe this is related to the secondary market or something?
Yeah, this relates to the time inconsistency problem, meaning that if we are talking about only one period, complete centralization is the best. There's no doubt about that. But if you have talked about the dynamics over different periods, you know, the complete centralization will create the time inconsistency problem, meaning that you know, it's not really like you know, the complete centralization here is not really the global optimal. Because as a manufacturer, you know, maybe the global optimal is I will produce 1,000 units the first year, and the second year I'll produce nothing. The third year I will produce nothing. You know, kind of commit myself and achieve this global optimal. But because of the, you know, the time inconsistency or the dynamics, okay. So once I produce 1,000 units in the first year, maybe I know I shouldn't produce in the second year, but I will still produce it. So because
okay, so you mean here that you are not obtaining the solution by backward induction. It's like you are solving forward.
Yeah, we're not doing that totally like a backward induction, meaning that is we don't solve the whole problem, because the whole problem, as you will see from other research, the best way is like produce only in the first period. Okay, choose the best amount, only produce in the first period. Okay, but because of the durable good nature, right? Every year you're going to make a decision, and you're going to produce. Yeah, so so it's a little bit hard to explain here, but basically, yeah, centralization means the supply chain is centralized. It doesn't mean the supply chain will do the global optimal for the whole planning horizon, for the whole decision horizon.
Yeah. Okay. Thank you for clarification. Thanks.
Thank you, George. Yeah, very insightful question. Yeah, so here says that partial centralization can be better, right? Can be better, which is interesting because, as we said, partial centralization meaning that I will say buy 30% of the retailer, right? Complete centralization means I go buy 100% of the retailer, right? Of course, buying 30%. If buying 30% is better and it's much cheaper, why not do the partial centralization? Why we want to do the complete centralization, right? And here is a picture to illustrate. And the x-axis will be the delta, the durability, and this one is the ownership share, right? And this is the threshold. As you can tell from here, as delta increases from 0 to 1, and this threshold decreases from 100% to about, say, 51%, right? So that means, for example, if, say, the delta durability is 0.8, as long as the manufacturer, say, has, say, about 58% of the retailer, is going to be better than complete centralization. And the second next result is about the same thing, but here we focus on the optimal ownership share. Okay, so there exists a unique ownership share theta star, which maximizes the supply chain profit. And here is the blue line. Okay, so as we can see here, as delta, the durability increases from 0 to 1, the optimal ownership share will decrease from 1 to about 80%. So this is basically one of the related results as this one. But basically, those two results, number one, shows that partial centralization is better than complete centralization, right? We do have a potential problem, which is that, as you can see from the threshold and also the optimal ownership share, the number is pretty high. Okay, so if you look at this threshold, right, the minimum threshold is about 51%, and for the optimal ownership share, the minimum is about 80%, right? Now, but in our model, we also kind of assume passive ownership, right? That means although I own, say, 80% of the retailer, I'm not going to affect I'm not going to directly affect their decision. Okay, which is possible, which may also kind of not realistic. Okay, if I have 80% of another firm, of course I have basically all the control I can have, right? So, so we are going to say that maybe because this model is quite, kind of abstract model, right? Maybe there are lots of things we have not considered, right? So in the extension, we do consider competition, and we show that if you consider competition among different supply chains, then those kind of thresholds will decrease a lot. So also we want to offer some explanations, right? As we said, complete centralization will solve the double marginalization problem, right? Now, complete decentralization can help solve the time inconsistent problem. Okay, as we said, time inconsistent problem means that over time the number of products in the market will be too high, right? And the price will be too low. So that is this problem, right? But by doing the complete decentralization, you will have double marginalization. So basically, you are going to keep the price higher, and you also keep the number of units in the market lower. So in a sense, CD can help solve only this problem. When we say PC is better, okay, that means this PC can solve the two problems at the same time. Okay, so can solve the two problems better than CC or CD, all right? And we have done some, extensions. One of them is the, more than 3 periods. So when the length of decision horizon is 3 periods or longer, in general, the results are analytically complicated, okay? We do have some, like relatively smaller results. For example, if delta equals 1, okay, the optimal supply chain structure depends on the decision horizon length. If you only consider 1 period, it's always true that centralization is better, okay? If the decision horizon is anywhere between 2 and 6, then PC, partial centralization, is better. When the decision horizon is 7 or more, the complete decentralization is better. So this basically tells us that if the length of decision horizon is long enough, then decentralization is better, okay? That means, because as we said, decentralization basically can solve only the time inconsistent problem, right? So, when the decision horizon length is 7 or more, that means the time inconsistent problem is quite severe, because as time goes by, right, you need to consider all the product in the market, and the number of units of products in the market will be higher and higher. So if the decision horizon length is long enough, CD is better, because in that case, the biggest concern, or maybe the only concern, is to solve the time inconsistent problem, okay? If the decision horizon length is not that long, 6 or less, then PC can be better. PC can be better. And also we show that the optimal ownership share will decrease with the decision horizon length. And then if delta is anywhere between 0 and 1, as we said, the results will be quite complicated. Then the derivation will be quite complicated. So we have conducted numerical studies by consider all the kind of different decision lengths, decision horizon length, 3 periods, 4 periods to 8 periods, and then we also generate instances for all possible values of delta, the durability, 0, 0.1, 0.9, 0, 1.0, and so on. So we have a few results here, but I'm going to skip those for now at least. But basically, they kind of show that if you increase the time, the decision horizon length, then those the threshold ownership share and those optimal ownership share level, they are going to look more and more realistic. So basically, for example, if the number of periods is say 6, okay, then as long as the manufacturer owns say 10% of the retailer, then PC will be better than complete centralization. We also talk about we also did another extension about supply chain competition. So suppose there are 2 competing supply chains, okay, and each consisting of a manufacturer and her exclusive downstream retailer, and the 2 supply chains compete with substitutable products, okay, and also the manufacturer is the leader. The manufacturer is going to own theta of the retailer, and we assume perfectly durable goods, and then we assume we focus on 2-period decision horizon. So basically, the whole thing can be quite complicated. So we we try to make the derivation as simple as possible. And in that case, in this case, the inverse demand function is also more complicated. So basically now you will consider also, the price you're going to charge your customers also depends on how much your competitor charges the customers, right? So again, we're going to skip the details, but one of the important parameters is K. Okay, so this is called the substitutability level. So if two products has a substitutability level of 0, that means the two products are not competing with each other. Okay, so if the substitutability level K equals 1, that means the two products are kind of identical. That means in that case, it's basically a price war, right? So whoever price lower will get more customers. So based on this important parameter K, we find that K is going to affect supply chain structure choice a lot. Okay. So again, we assume delta equals 1. We assume there are two competing supply chains under the two period setting. So here says if K is between 0 and 0.22, then centralization is better. Okay. When K is between 0.22 and 1, complete decentralization is better. So here again, this proposition, we limit ourselves to the two choices, okay? Complete centralization and complete decentralization. So we say that whether which one is better really depends on K, right? So recall, previously we showed that without supply chain competition, meaning that there's only one supply chain, right? There's only one supply chain. CC, complete centralization, outperforms CD for any delta. Okay, so CC is always better for any delta, but that means also CC is better than CD for delta equals 1, right? Which is the perfectly durable goods. But here says that actually CC is better only when K is relatively small. Okay, as long as the competition is high, it's kind of high, 0.22, right? So this range is very high, right? If we say K is anywhere between 0 and 1, right? So this range is about 22%. It's only 22% of the whole range. Only 22% of the time, the complete centralization will be better. Most of the time, or when the substitutability level is relatively high enough, then the complete centralization is better. Okay, so again, this tells us which one is better depends on competition level a lot. We also have done some research for any so for basically for any K, but now we have two competing supply chains. We also now we consider all the three options, okay? PC, CC, and CD, right? So basically the results are a little bit similar, which says that if K is between 0 and 0.22, PC can be better as long as the ownership is within certain range. If K is between 0.22 and 0.77, PC can still be better, okay? But if the K is large enough, then CD is preferred. Sorry. So basically we are saying that, when the two supply chains competition level is really high enough, then, in that case, the biggest problem is what? Is that the products, because they are similar enough, right? That means, the two supply chains, we are kind of engaged in the price war. The price is too low, right? And how do you address the problem of pricing too low? Well, you can use the complete decentralization, because by using complete decentralization, you're going to have double marginalization, which make the final price to the consumers at a good level, okay? So basically, again, we're going to skip the details, but basically we show that supply chain competition really affects the choice quite a bit, okay, but doesn't change the result fundamentally, because we are still seeing that PC will be better for a range of product substitutability level. All right. Okay, so due to time limits, I'm going to just go to the conclusions and quickly. So our findings about durable goods supply chains, one is, partial centralization can be a equilibrium structure which outperforms both CC and CD. And we argue that PC can be the best because it can effectively solve the double marginalization problem and the time inconsistent problem simultaneously. And specifically, we show that the manufacturer's equilibrium ownership share in her retailer decreases with the product durability. So if the product is more durable, the equilibrium ownership share is going to be lower. And the manufacturer's equilibrium ownership share in her retailer is going to decrease with the decision horizon length. So if you consider longer decision horizon, then the ownership share equilibrium ownership share will be lower. About future research, and we believe there are lots of possibilities. One is to consider cross ownership. Okay, so maybe the retailer also owns, a certain part of the manufacturer. We can consider the interaction between PC and information asymmetry. So in this research, we did not consider any information asymmetry, right? So what if you have asymmetry in terms of product durability, in terms of product demand? And the third one I also think is very interesting. So how a manufacturer and its retailer negotiate their partial ownership levels. Because in this research, although we say there's optimal ownership share, but in reality, when two firms kind of try to own each other, buy each other, a part of each other, there are lots of considerations, right? So we don't know what will be the main issues when you negotiate this kind of ownership levels. So maybe that relates to financing and so on, right? Number 4, what if the manufacturer can set up its own direct selling and leasing channel, right? As we said, leasing can solve the durable goods problem. So how about you consider leasing in your model? And then you can consider multiple competing manufacturers and multiple retailers. Okay, so I think my time is over.